In today's video, I will be discussing about the assumptions made in the theory of simple bending. So here the first assumption is the material of the beam is homogeneous and isotropic. So here what does this mean, homogeneous and the isotropic? Here homogeneous means the material of the beam is homogeneous. So here the beam should be made up of same composition. Composition means a material. It can be in terms of material throughout. And this isotropic means here the Young's modulus is same throughout. Throughout means along x, y and z direction. Now the second assumption is beams is straight before loading. This part everybody knows, and here it remains straight even after load is removed. This means here, see, suppose this is a beam and we are applying a load over this beam, so it will deform like this, but the deformation should not be a permanent deformation. So what happened, when we remove this load, it will come back to its original shape and size. Okay, so now the assumption number 3 is beam is subjected to pure bending. So now here pure bending means here the beam is subjected to only bending. That means no shear force is applied on the beam. Here the shear stresses are not to be considered in case of the pure bending. Now the fourth point is the layer of the neutral axis. The layers of neutral axis does not take part in bending action. Here this means, see, this is the beam and we know that this is the neutral axis of the beam and A. So suppose what happened, when we applied a load here, obviously this beam will get deformed, but the neutral axis of this beam will remain same. Only the upper and the lower part of the beam will get changed. Here you can see that this layer, the upper layer, is less than the lower layer and it's subjected to a compression force, and this is subjected to a tension force. Here the neutral axis of the beam will remain same.